This is Corwin Point. It is an ESP32-driven dual voice generative analog synthesizer which optionally doubles as an instrument. Structurally, we can divide the sculpture into 5 parts. We have a bottom plate, a middle plate, a user interface, a speaker enclosure, and a tower onto which the light pipes are attached. These architectural elements all have electronics either inside or mounted to them. As for the electronics, we have a motherboard on the bottom plate which contains the digital components, meaning the ESP32, LED drivers and digital to analog converters. The middle plate, which also hosts the user interface and tube overdrive, contains all the analog electronics which are used to generate sound. The speaker enclosure contains a 5-watt amplifier as well as some peripheral electronics for the Seed Studio VO terminal which is mounted to the left of the speaker. Finally, the back side of the tower has all of the delay circuitry attached to it. The user interface on the left side houses 6 potentiometers which can alter pre-programmable parameters. At this moment it is set to amplitude envelope, cutoff and resonance frequencies for both voices, but it can also be reprogrammed to control other things with a few limitations. There is also a reset button, delay on and off switch, tube drive and a toggle for manual mode which allows you to take control over the previously mentioned parameters. Due to the random nature of the algorithm, which effectively composes the music, the reset button is handy when you want a better starting point for the composition. It is also nice to be able to turn off the delay if you want a clean signal from the line output at the back. The analog section is using alpha reproduced CEM33 series chips for its oscillators, filters and VCAs, with the control voltage supplied from the digital to analog converters on the motherboard. The resulting signal is sent to an ECC82 vacuum tube before it is split between the delay and the Seed Studio VO terminal, which provides a real-time 32-band FFT analysis. In addition to 18 intertwined LED light pipes which mimic the amplitude of the 2 voices, as well as other parameters represented through color, there are 2 sets of white LEDs on each side of the sculpture which follow the rhythmic progression through the sequencers. The entire algorithm is in fact based on these sequencers, and they are an important factor in the way the music progresses through time. If you have seen my previous videos, you already know a bit about how I work when I construct these things, so I won't go too deep into the details in this video. Anyway, I plan everything from the design to the wiring, the physical locations of the various parts of the circuit, as well as drill maps and dimensions for cutting in SketchUp. Here, for instance, all the wiring information is hidden in a separate layer for reference. It makes it easier to keep track of where each wire is going and what signal it carries. As this project was a fairly long and drawn-out process, stretching from February to September of 2022, I only documented the construction of the speaker enclosure, for which I'm using 8mm thick black acrylic glass. I'm using a fairly standard 24-teeth blade with a rake, which is okay because I will sand all the edges at a later point. Here I have the drill maps. They are printed to scale with a regular printer and then cut to size and attached to the acrylic glass. I then drill all the small holes with a drill press and cut out the larger holes with a jigsaw. Everything so far could probably have been done in 12 minutes with a laser cutter, but I quite enjoy the manual labor. Now I will just check that the dimensions are correct and that everything fits. I'm also trying something new here. Instead of using brackets to join the acrylic, I will tap holes into the edges, and I'm hoping it will be fine without having to use inserts. I'm aiming for about 10mm deep holes, and I will use an M3 tap for the threading. And again, I'm just checking that everything is lined up nicely and that the threads are clean. Finally, I'm sanding the edges. I'm starting at about 60 grit and moving upwards to maybe 400. It's important to keep the sander straight to not round off the corners. Again, a laser cutter is probably a better solution. That's it for this video. If you liked it, check out the other videos and live streams on my channel, and I hope to see you in the next one.